So, um, so I think in this class, I will try to cover both the theory and the interactive session classes content. So, so when I talk about the content that is covered so far, we have covered the um, introduction to IoT, introduction to IoT. In there, we discussed about the main components of an IoT network, and how we can actually define an IoT network. What is IoT? The definition of IoT. So basically, we will talk about this again. I mean, we are another slide presentation. So I'm just giving you the overview of what we have covered. So after understanding what is the basic, definition, or what is the basic meaning of Internet of Things is, then we looked at how we can, uh, you know, um, how we can visualize an IoT network. What are the basic components of an IoT network? Afterwards, we also looked at the history of IoT networks, history of IoT, where we talked about how IoT evolved and what are the initial IoT implementations. Afterwards, after discussing about these components, we talked about the uh, current and future IoT, future IoT networks. So in here, we talked about how IoT is currently used in the world, in some developed countries where IoT is very popular and is used in their daily life. Um, so IoT-based smart cities are very popular. So when we talk about the future IoT networks and IoT systems, there are many technologies that we have proposed to be used with the IoT networks. And some of those technologies are, for example, like digital twins, where we will actually talk about these things as well. And then Internet of Nano Things, and so on. So many IoT based implementations are yet to come, and those have been proposed as future implementations, and some are already, in the in currently, some are already in the research level, and people are trying to build those IoT systems with more stability and reliability. So, with the first section, we have covered these discussions, and we have actually done that within a short time. After that, currently we are talking about the physical design of IoT, about which I will get into in a later day. So first of all, I think I will, in case you have not gone through the slides, I will just go through the slides in a little bit, uh, and then I will explain to you about what we can cover with regard to the interactive part of this module. So yeah, so I would like to give a brief introduction about IoT definition and the characteristics of IoT. And also, I want to give a small introduction about what are the module related details. So basically, you need to find the details that are available in the LMS web page. If you, have access to the LMS, please go and visit that and find the resources already available there. All the lecture notes, lecture videos are already uploaded, and then module outline is available there. And then we also have the assignments and any other tasks already uploaded there for you to submit your work. So in this module, we'll be basically learning about IoT and IoT concept and how it is used in different applications. But from that, in this module, we are trying to design IoT, networks or systems, IoT systems, which can, cater some service to a certain user. So we are going to, design an IoT system based on a given specifications, and then we are going to in that design we are going to consider mainly different constraints related to that environment and choose the best system for that application. So in that journey we have to have an understanding about the technologies that are used in an IoT system. So that is what we are learning in this module. We are learning about the different technologies that go in hand with the IoT systems and how we can use them optimally to a specific, to a certain application. So the module outline is already uploaded in the LMS, so you can have a look at it if you have the access. So when I talk about the IoT, networks and the definition of an IoT, Internet of Things, it's basically a network of physical devices or sensors or sensor. Actually, uh, it's a network of physical objects or things that are having sensors and other um, hardware and software for the purpose of connecting uh, those sensors with other devices and other systems over the internet. So, in an IoT network, you will find a thing, some kind of a object or a sensor node that can collect data about the environment and process that data and transmit that data to a certain access point. So the access point that connects the different networks together is known as the gateway. So the gateway can be a router, or else, the gateway could be a certain, server-based router that can connect the local network of the, that can connect the local network in which we have established the IoT network with another different network. So the gateway connects the two different networks together by considering the protocol changes. And then afterwards, the data that is transmitted from the gateway will be reaching the internet, and it will go across the internet towards the destination. So after it reaches the destination, the the data that is stored in that location will be analyzed using different mathematical and statistical methods. And then after making the analysis, the important data that are gathered from the system are sent or transmitted to the user interface or the UI of the customer. The customer can, from that user interface, access the data that is sent by the cloud server. So basically, these are the components of an IoT network that can be seen in any of the standard IoT systems. The IoT is therefore a necessity in our day-to-day life as of now, because we want to connect our our data or our devices to the internet and gain information about our environment, and also provide information uh, to the internet and to the servers about our environmental conditions. So, so I will go, briefly about these sections I have covered before. So, when we talk about, different IoT applications, we have to consider different factors. So when we are designing the hardware of the IoT, we need to select the specific sensors that are useful for the IoT application. And so this figure shows the application of using smart agriculture, uh, which is IoT assisted smart agriculture. So when it is so when it is connected to the internet, when the sensor data are connected to the internet, we can call that architecture as IoT network, where we have both the sensors data and also we have connectivity to the internet. So this type of a IoT network is enabled through multiple technologies. So one thing is we need sensors, sensors that can sense the parameters of the environment. So if you are going for a smart agriculture application, then we need those relevant sensors in the environment, in the IoT network environment. So after selecting the correct sensors, we can we can take the measurements of different parameters, and then we can convert them into certain information in the processing units, uh, which are connected to these sensors. After processing the data will be generated to suit the data transmission in terms of packets. Then they will be transferred to the access point that is closely available. Could be an access point with cellular communication, or it could be access point with Wi-Fi communication. So anyway, like there could be multiple communication technologies. It could be other technologies such as LoRa, narrowband IoT as well. So based on the available communication technology and the most suitable communication technology, we can use that technology, and then we can use it to transfer our data from our sensor nodes to the access point. once the access point reaches or receives that data, the access point will transmit the data to the internet through if it is the normal base stations, then it will connect the data or transmit the data through the core network towards the internet. And then the internet, which is consisting of like thousands of routers and switches, will forward the data across multiple nodes to towards the base station, so sorry, towards the destination. So the destination will receive the data, and the destination will receive, data from a very remote location. So the farmers or the owners do not have to come to the field. They can remotely monitor the field from somewhere far away. So this is the advantage of IoT. So IoT is a uh, is a system that enables us to monitor the IoT system from a remote location without coming to the network all the time. And I mean, the um, without having to face any kind of difficulties of having to monitor it all the time. The IoT system can provide it for you, even if you are not near the field. So this is the IoT based smart agriculture application. So based on those applications, we need to design these sensors and communication technologies. And then afterwards, once you transmit the data through the internet, we also consider the networking technologies that we require. And then after networking through the internet, through using such kind of technologies, then the data needs to be analyzed, managed, stored in the cloud server. So there we have to use computing technology. So cloud computing, edge computing, fog computing. Likewise, we need to use the best computing method. So after that, we can do modifications, or we can do predictions on the data that we have received, such that we can, give a useful information regarding the data we have to the environment and to the community. So we can use machine learning to predict the next outcomes of our IoT system based on the data. So, so such kind of technologies will be added to this IoT system, like machine learning and other technologies that are emerging, and those data uh, will be therefore those data also has to be viewed by the customer. So the data has to be sent to the customer via a good method, and the customer should be able to receive the data very easily, and the customer should be able to define what they want from this IoT system and get that information. So basically, when we talk about IoT networks, those are the main basic components. This is another figure of an IoT component based network, where we have a set of sensor nodes where the sensors are collecting the data from the environment. It could be temperature, it could be motion, it could be another alarm. And after collecting the data, that data is pre-processed in a manner such that it can be sent over the wireless medium. And then if it uses LoRa communication, it will use LoRa communication technology in the physical layer. It will use LoRaWAN protocol in the network layer. And the gateway, once it receives all this data from the local area network, it will transmit the data to another network, which is connected. Which is connected to the internet, and the gateway will enable the protocol transmission. Protocol. The gateway will help the devices to connect from one protocol to another protocol. Then after you connect the data to the internet will transfer the data to the necessary destination, and the destination could be the cloud server. The cloud server could be there could be some specific location in the cloud server that receives this data, and then that data will be processed and analyzed in such a way that it can be presented to the user, and then such data will be sent or transmitted to the necessary application domains where where the data will be shown to the user through a certain user interface. So that those are the basic components of an IoT network. So as an IoT designer, you have to have some skills in, like coding embedded systems and uh, building IoT, based, sensor nodes, hardware implementation of the sensor node that can collect data from the environment and do the pre-processing of the data in the embedded system itself, and then prepare it uh, in a suitable manner to be transmitted over the medium. So, an IoT designer or a IoT design, we don't call it IoT engineer, we call that IoT designer. So, IoT designer will be able to get that, will be able to, do the hardware design, hardware implementation of the IoT system by using the sensors that are suitable for this application, and also doing coding on the embedded system such that the sensor data are appropriately collected and they are transmitted appropriately to the access point. So that is basically regarding the hardware implementation. The IoT designer also must know how the communication technologies work and how which communication technology should be used out of the many wireless technologies, for example, that are in existence. So based on the application, they need to think like what is the best technologies to transmit data. Apart from that, we also have the other technologies that we have to know in order to implement an IoT system. So basically, as I said before, like skills related to networking, computing, machine learning, electronics, and communication are all combined into building an IoT system. So the knowledge of all those areas are kind of important if you want to be an IoT expert. There are many IoT platforms that are there in the world for people to use. Uh, and these companies are providing it as third party services, and therefore you need to pay for these platforms in a considerable manner. So, however, like these systems, these platforms have built IoT systems that are very popular and very secure and also very reliable when it comes to securing the data of the users. So once you enter some data into these portals, then those platforms will able to save the data and pass it or forward it to the correct community or the destination. So these third party protocols, sorry, these third party platforms are able to safeguard the data and transmit the data reliably to the destination. So the data could be massive data. There could be massive devices that are connected to these platforms. However, there are many resources in these platforms that enables them to cater multiple devices at the same time. So that would be another advantage of these platforms. So the platforms have higher functionality and a high analyzing power than what we have when we build in an IoT system from scratch. So these platforms that are already built and are available are reliable and very popular among the customers because they have the distinct method of ensuring the security, ensuring the data management, and everything from start to end. So these platforms are popular among the people. So when we are designing an IoT platform, I mean, as I mentioned before, there are many IoT platforms that are popular, and almost all these IoT platforms, define their own protocols to transmit to manage the data in their system. So they have their own standards on managing the data, on securing the data, on storing the data, and so on. So all those features are enabled in these IoT platforms. So, do you think that smartphone is an IoT device? Yes or no, as you think? Yeah. So, yeah. So you have one of you have said yes. So, actually, I think also that, I mean, IoT device is something that has the sensing ability and the communicating ability. So smartphone is a device that has sensors that can collect data about the environment and process the data and communicate it. So it has both the sensing ability and the communicating ability. So with those two skills, the smartphone is able to act as an IoT device. However, like, it is much more complex than a normal or general IoT device. It has many functions and features in it. It's almost like a computer. So it can stand alone, work on its own, and it can also transmit data to the internet. So it's a very highly advanced IoT device. The normal traditional, devices that came in the past with the phones, I mean, with phones that do not have the connectivity to the internet, are not considered as IoT devices. So there are many standard organizations that define the standards for the IoT systems that we propose. So if you are going to propose a new IoT system, the communication and what are the I mean, hardware or some kind of a technology if you are using, you need to check whether the all these entire IoT system that you propose follows the proposed standards in these under these groups. There are many groups who are defining the standards for IoT networks. So one is IEEE, another is ITU, another is IETF, another one is ETSI. So these kind of organizations are there to give us the standard protocols on, I mean, the standards in using the IoT systems. How we can build an IoT system, how we can do the transmission in that IoT system, what are the like standards ways of doing the communication, and so on. So these standards must be referred by the all the vendors who are building IoT systems, such that these all the designed or, I mean, proposed IoT systems that have been designed to for for the usage of customers must be following certain standards. So that must be compliable with the so the IoT device must be compliable with the standards, so that it is I mean, any user, I mean, a user can easily use that device. If different companies use different standards to build an IoT network or a IoT system, then it's difficult for the customer to find the necessary equipments, other resources necessary to connect that device into their system or into their network. So if all the designers, IoT system designers, if all them are following a certain guideline standards when they're doing or when they're creating their own product, then it's easy for the customer to integrate it to their own available systems. When we talk about the history of IoT, it is known that the world's first IoT device was a Coca-Cola machine, which was connected to the internet. So, a group of people who wanted to know whether there was Coke in the, in this machine, had set up some sensors in the machine such that they can remotely monitor the existence of Coca-Cola inside this machine. So that data, which was collected by the sensors, based the sensor node, was transmitted to the internet. So using the data available, I mean, with the access with the available data and with access to the internet, any person who can access the internet can access this data if they know how to access it. Then that is how the the first IoT device has been built. But from that, afterwards, this person who's known as the Kevin Ashton is the innovator and the consumer sensor expert who uh, who brought out the term Internet of Things in 1999. So this term was used to describe a network that can connect objects in the physical world to the internet. So his main definition of IoT network was that it should have sensing ability and communicating ability. So if both those features are enabled in the IoT in a certain network, then we can call that an IoT network. So there are many applications currently ongoing in the world related to IoT networks. So we can see smart cities available in Switzerland, and smart inventory systems available in US and so on. So such kind of applications are available already in the world. When we talk about the future of IoT, we can see multiple technologies are getting uh, getting uh, getting applied into the IoT system. So we can see machine to machine communications. Machine to machine communications means like one machine communicating with another machine directly. So direct communication between two machines is something that is already ongoing, and people are researching on that. That is also part of the Internet of Things. So Internet of Things means connecting everything or device into the internet, which means that every device can also talk to each other through this IoT network. So machine to machine networks are part of IoT, the subset of IoT, and in there we can call that we have a one machine that directly communicates with another machine. There are other concepts such as Internet of Nano Things, and in there we have nano devices or nanoscale devices, which are really small, that can be installed in really, places such as the buildings, concrete buildings, and the reason is that by doing so, we can monitor the behavior of buildings, for example, and we can get the information about the stability of the building, what happens to the building if some kind of a weather problem arises, or if some other problem arises in the environment. So we can get quick updates from our environment if we can install as much as sensors as possible in the environment and get data from them as frequently as possible. However, this is kind of a hard thing to do, like placing sensors everywhere and also making sure that we receive the data from all those locations. So if you are deploying maybe 100,000 millions of sensors, then we need to have the capability of obtaining or receiving that data and also storing that data reliably in some kind of a location. So although we have these concepts, still the work is progressing and the research works are going on. And then we have wearable IoT, where the IoT enabled, devices are there for wearable accessories like watches, uh, t-shirts. Even they have their small chips installed in the t-shirts, and those t-shirts also can be considered as wearable IoT. And then digital twins. Digital twins is another concept that has come in the world of IoT. So digital twins is something that is already available in companies such as Orel, which is very near to SLTC. So digital twins is another like emerging trend that is coming into the play when we talk about the IoT. So digital twin means actually that if there's some kind of a physical process that is happening in the world, so we can say some kind of actual physical process happening in the world, the digital twin is able to recreate the same physical process somewhere else, however with softwares. So using softwares, the digital twin is created. So the digital twin will be able to uh, basically, create the same effect or the same behavior of the physical scenario or the physical process, right? The softwares are able to bring out the same behavior of the physical process using softwares. So the software-based system that we can build to emulate or mimic the physical process is known as the digital twin. So by building digital twins, the administratives are able to monitor another process happening in another very remote location without going there and without going to those locations. They can view and they can test out different technologies by using the virtual mimic of the actual process. So digital twin is also an emerging field, therefore, and it is currently in use in several companies, even in Sri Lanka. And then cloud computing is another area where we will see some changes with IoT and some kind of advancements in the current cloud computing. And then we have other applications as well. I think we will, discuss one or two. However, like another IoT is we call as super IoT, and we call this super IoT. As I understand, is mainly because the IoT network is able to power. Uh, generate their own power. That means like we can leave the IoT network or IoT sensor nodes somewhere in the environment without having to power them up. So that is those kind of networks which generates their own power and then also transmit information are known as this, these IoT systems, super IoT systems. So that is one thing. So these kind of, super IoT systems. Super IoT systems are sustainable IoT systems, which means they can produce their own energy and they can do their functions on their own, standalone, without requesting for help. So these are the kind of IoT networks that are in target in some research labs in around the world. So this is one of the professors who's working in University of Oulu working on this super IoT concept. So therefore, like these are ongoing work in developing countries, for example, and these are I think some focus areas for them when they are building the IoT systems. When we call about the mission critical applications, even in there, when we are doing, for example, like operations on a patient, then if the if the doctor is able to connect through the IoT remotely, then we can easily monitor. The doctor can easily monitor the patient using the IoT system. So sometimes this is going to be a very good service to the people who cannot access doctors in other areas. So rather they can connect to the IoT network and talk to the doctor or other kind of you know uh, person. So likewise, we have many IoT applications. So we have different characteristics of IoT applications. So I will not go into each and every detail, because I think I have already explained most of the characteristics. So anyway, like what I want to say is that even though we have all these IoT applications, although we have progressed a lot, there are still some challenges with the IoT systems. So we will talk about those challenges maybe in another time. So just in case you want to know, like IoT systems still struggle with, different application. Different um, conditions. So IoT systems are not favorable for each and every application. We need to customize it such that it is suitable for that specific application. So when we talk about the, like well-known IoT devices, there are many, anyway, like many IoT devices that are in use. So people use for example, Alexa, a voice activated IoT device for smart home applications and for smart home usage. So, this is one of the IoT devices that can collect data from the environment and respond to the commands given by the user by accessing the data that are available in the internet, in the cloud servers, for example, and then giving the accurate data or the useful information to the customer. So there are other products such as Siri, which is also voice activated intelligent personal assistant. Okay, so when we talk about the, um, I mean, after talking about those IoT devices, we also have other IoT devices such as wearable IoT devices. So these wearable IoT devices are currently in the market and people are using them already. And these are consisting of, as I said, like watches, glasses, glucose meters, fitness meters, and so on. So these meters are used to collect the data, and also, they are able to connect to a certain central server through different communication technologies. So the communication technologies could either be wireless devices, wireless communication assisted, devices, or else it could be wired devices that can be connected through Ethernet, USB, or something. So there are many wireless communication technologies, and namely we can say we have the Bluetooth communication technology. We also have Bluetooth low energy version, which is the low power, however, kind of considerable data rate. Um, Technology. The Bluetooth Low Energy is highly, convenient for IoT networks because it uses low power. So low power is something that we are targeting in IoT networks. However, we also want to achieve high data rates. So we need to select the best communication technology based on our requirement. So it could be that we don't really need a high data rate. It could be that we might need lower data rate, but we need, low power. Low power is something considered to be optimal, or low power is something what we are trying to achieve all the time in IoT networks. And then when we talk about cellular based networks, cellular communication or 4G, 5G, based communication networks, even those communication networks, we have a very high popularity between the people. People like to use cellular technologies for their work to connect with another person. It's very familiar to the people. And apart from all that, it also can, reach long ranges. And the communication can be done over a long range. We can do communication up to kilometers of distance from the transmission, and then we also can achieve high data rates. So depending on the generation that we are using, maybe 2G, 3G, 4G, we might not have high data rates, but with 5G, we are going for gigabits of data transmission. So the high data rates of can be expected with the cellular communication. However, it uses a little bit of high power for the communication or the data transmission. Then Wi-Fi communication is used widely for different applications, especially for short range communications within maybe 1 to 10 meters of distance. So we have Wi-Fi communication in basically in indoor scenarios. We also have this in outdoor like public scenarios, but the communication range is a little bit low, and therefore we can only do some communication within that short range. We also have Zigbee communication that has low power, however, low data rates as well. And that also can communicate up to a certain level of about 10 to 100 meters of distance. And then NFC is another communication technology that is used with IoT devices. It is known as the near field communication technology. So near field communication technology is something that is used for example, payments using, contactless, uh, uh, the payments that we can do based on contactless payment method. So, I mean, we don't need to, bring our cash. We can use our phone directly and then place it over the payment machine to get the payment transfer done. So, in this machine, in this near field communication, uh, it is transmitting the data which is encrypted. So the data cannot be decrypted without having the users a password or the primary keys with the receiver. So therefore, the transmission is like considered very secure when compared to other data transmissions that happen, for example, RFID. So RFID communication, although it can also transmit data from one location to another, it does not provide secure transmission or secure data transmission as NFC. So NFC is having some encrypted data, and therefore it can transmit secure data over the medium to the receiver. We actually, those are the basic things that we discussed about the IoT fundamentals in the first section or of our lecture. So after the end of the first lecture, I did the interactive class. So in the interactive class, I discussed mainly about the interactive work that we have to do in our in this module. So let me first, show you the module outline and basically the LMS page that is, that is dedicated for the IoT, and I want to explain to you um, about the work that we have to do. So the after in the first week, I have uploaded something called the IoT group project. So I would like to explain to you regarding the IoT group project now. So I have provided you like Google Sheet. You can provide your group members' details in this Google Sheet. There are mainly maximum of 3 members per each group. So if you want, you can work individually as well. But if you are going with a group, then you can mention like group details in here. So basically after that, you need to like refer this instruction sheet. So the instruction sheet is having all the information that that is there. Regarding the project. So the project is remote monitoring of Coke cans in a fridge using ESP32 and MQTT protocol with real-time updates on smartphones. So actually, this project is not that a difficult project to do. However, like I need to teach you about ESP32 microcontroller, how we can do the coding in there, what are the kind of technologies that we can use. And then I have to teach you about the MQTT protocol, how it works, and how to make it, how to uh, get the data transmission done in the way we want using this MQTT protocol. And then also I need to inform you about how to get the real-time updates on the smartphones. So what we're trying to do basically here is that we are actually trying to monitor some Coke cans or any other item that is there in a fridge from a remote location using our own smartphones. So that is what we are trying to do here. So I think I have given the deadline as November 15th for the group detail finalization. So if possible, you can, do this, finalization of groups by today, if possible. Otherwise, you can take your time since you started the class today. So I will give you 1 week to finalize the group members. In this project, you have to build a system that can monitor the temperature and the temperature of the Coke cans or the items in the fridge and send the real-time updates to a smartphone using the MQTT protocol. So the system will notify if the Coke is available and its temperature is below a specified threshold. So that means that the system should give some kind of notification when there's Coke and also when the Coke is below a certain temperature threshold. So you need to define the threshold in the code, and you need to define like if this that condition and also the Coke availability condition is satisfied, then we can notify the user. So notify the user about the good news that there are some Coke in the fridge with below a certain temperature. So for building this, we need ESP32 based development board, right? There are many, ESP32 based microcontroller boards in the market. I have given you links to the, different shops that sell these items online, and then you can get it delivered to your own place. So you can go through these, links and try to find out whether you can, find a good ESP32 development board. Apart from that development board, we have the temperature sensor, ultrasonic sensor, jumper wires, the breadboard or any kind of PCB board, then USB cable, Coke cans, and a fridge. Right. So this part, I think you can, can get it done from somewhere if you don't have it. So what I want to do is just buy ESP32 microcontroller, temperature sensor, ultrasonic sensor, basically, and then you can build the other components with whatever the wires you have and the breadboards if it is required, and then combining the or connecting the ESP32 to the computer and do the coding and maybe burn the code in there and then give external power supply to the ESP32. So we will get into those areas about the ESP32. So apart from that, you have to use programming languages such as MicroPython or C++. So I recommend not using the Arduino IDE for this project. Mainly because normally SADC does not allow the students to present their project works with the Arduino IDE, saying that the main reason is that the students are able to get the libraries directly and get some work done without actually thinking what happens in the library. So what you can do is you can actually implement these systems or this IoT system in another IDE that does not use the Arduino language. You can use other IDEs that are available. We will discuss about that as well. Apart from that, now what you need to do is here given in here. I will explain to you about all this, MQTT protocol while once I'm coming to that section in the theory class. So up to the point where you can, run some code in the ESP32, you can, complete the tasks. Afterwards, you need to learn about the MQTT protocol and establish the MQTT protocol in our ESP32s, and then do the protocol based transmission, and that data will be received by MQTT server. This MQTT server will transmit the data necessarily to the necessary users. So that is basically regarding the necessary work to be done. So up to now, I think you can, do up to step 4. So apart from that, once you have completed the project, you need to do a presentation, and you need to give a report about that presentation. So the presentation does not need to be like actual live presentation. You can video your presentation and you can submit the video. And then the report has to be written by each member individually about the things they have learned about the project. And then they need to, include even their members' contributions into the report, but the report must be unique to each member in the group. And then, what I mean is the same report cannot be submitted by each member. And then you can follow the structure or the standard format that I'm expecting here when compiling the report. You can create an introduction part, literature survey, methodology, results and discussion, then video presentation. Those sections you can include in your report, and then I think you can provide a good comprehensive report. And then one thing I want to emphasize is that you definitely need to include the results. The results that you obtain from your project, you need to include in there. Otherwise, I will not be able to give you good marks. And then reference links are available, which makes you able to, go through these reference links and refer the data or the information or the guide that that it's provided through these links, right? So you can refer from all these links and then you can try to get the information. So do you have any questions related to the project? Right? So currently the deadline has been set to Monday, January 15th. So since you joined about, I think, 3 weeks after, I will give you another deadline, which would be 3 weeks after this date, right? Is it okay? Maybe, I don't know whether you will be following this module or not. If you don't want, then I won't be extending. It's just my suggestion. So this is the deadline as of now. Even you have to submit it up to by this time if you are doing the project. So the project actually contributes about maybe like a considerable mark to the final grade, and like mostly about 20% of the final grade will be from the project. So therefore, the don't like take it lightly. The project contributes more to the end results, and the end exam also contributes considerably. But on top of that, project is the next big thing. Then we discussed about different things during the interactive class. So I would like to discuss about the those sections now. So in the LMS, I have uploaded the data sheet of the ESP32 microcontroller. So when we are working with the ESP32 microcontrollers, it's very essential that we refer the data sheet. The data sheet contains all the information that you need to connect this ESP32 to different sensors or any kind of other devices. So when we are connecting, we need to make sure that the voltage levels and other like current levels are up to the standard. Otherwise, this microcontroller board will burn. So we want to protect the ESP32 microcontrollers, and therefore we need to refer these data sheets properly and use them accordingly to connect the objects, as I said before. So the ESP32 has different, like different microcontroller series. There are many microcontrollers that come with this ESP32. So the chip that is coming with the ESP32 is known as, a chip that comes with the ESP32 microcontroller is known as the ESP32 W Room 32. So this module is the chip basically that contains the all the uh, that contains all the necessary components to build the necessary algorithm in that controller. So it is the main component of the microcontroller board. So this is the module that is in the ESP32 microcontroller. So the basically there are many things that we can refer in this data sheet. There are different uh, different there are many information about the different components of the ESP32, and the first one would be the pin layout of the microcontroller. So there are many pins available in the ESP32 for different tasks. So when we take uh, these all these pins, there are many applications for these pins, right? So do you have any questions to ask from me so far? If you have any questions, you can let me know. So
Excuse me, madam.
yeah.
Madam, what is the preferred applications for using C++? Actually, I am using Arduino IDE as well as VS Code for C++ programming.
Uh-huh.
Uh, by writing the library is a very difficult task for me.
I mean, so you're asking like why do we need to use another IDE? Is it like
Yes,
that?
uh,
So
what do you prefer?
actually, I mean, now in SLTC, they are preferring, an IDE apart from Arduino because, as I said before, there are already built-in libraries uh, that are there in the Arduino IDE. That is the main reason that, like, Arduino IDE is not preferred. Like, from my perspective, I think that you should be able to use all the IDEs. I mean, like not only Arduino, but also other IDEs that uh, allow you to do any kind of application development or algorithm development. We will get into that a little bit later also, but since you asked about it now, I think it's a good question. So what I want to say is that Arduino IDE, it has many functions like libraries and gives more features. But one thing I have noticed is that it's very time consuming sometimes. When you're running a code, you have to wait for a long time for the output to be shown. Like I had to wait a long time, and then finally sometimes I see there's an error or it's not working. So something, it's very disappointing sometimes. So that, like when you're developing something in a like such kind of a embedded systems, sometimes what we are trying to do is we try to get it as soon as possible and make it efficient. So we don't want to work with like operating systems or IDEs that are time consuming. So since Arduino IDE is having more features, it's having more delay. When you compare with the other IDs, for example, like we have other IDEs that are widely popular. I think I can show it to you. So I want to recommend to you, like there's this uh, website called Random Nerds Tutorial. I will show you. We'll put this link in the chat. this website provides, you know, like like multiple data or information about the ESP32 microcontroller and what are its features, and all the most of the things that you can do with the ESP32. So one thing I wanted to show is that the IDEs that you can use with the ESP32 or something like that. Like we have different IDEs that are coming, uh, that are compatible with the MicroPython language, and that we can use to code embedded system. So MicroPython IDEs, there are many ones. So one of them is MU Editor, UPyCraft IDE, Thorny IDE. So VS Code plus PyMaker extension can be used to do the coding. So maybe since you're using VS Code, you can maybe install this PyMaker and then see whether you can connect to the embedded system, and then whether you can run a sample code. And then you can use PyCharm, Micro IDE. These are the IDEs that you can use apart from the Arduino IDE. One thing I don't know, for me, I understand that it's very easy to get a code running and it's very quick when we are working with this code. So when we have a large code, it might not be, the Arduino IDE might not be the best method to work with when we are running that code. Apart from that, if you're using Arduino board, for example, Arduino board, it's not having much memory capacity. It's having maximum of, I think, 2 GB or 1 GB of memory capacity, RAM, and like other memories components. So the amount of data that you can store is limited, very very limited when you compare with the other microcontroller boards. So those are the kind of negative aspects that you can see with the Arduinos and Arduino IDEs. So when I think best thing is you try to install many IDs as much as possible, and then try to see which ID suits you. So once you're happy with your own IDE, then you can work with that. So if you can work with MicroPython or C++ aided IDEs, I think that you will be able to maybe understand the logic uh, bit more, rather than obtaining the library itself and then using it. Sometimes there will be more learning once you use these editors from and use an algorithm from a certain other source, and then you develop that in the IDE. So main idea is that Arduino has many libraries, but it doesn't give us the information about how that library was developed or how they define those functions. That information is not there. So we don't really know that the library gives accurate information to us in all the cases. So we need to ensure that, and in order to ensure that, we might need to do implementations regarding that same application or same thing, using our own our editors, code editors, and then we can develop our own libraries. I hope I answered your question somewhat.
Madam, excuse me.
Yeah.
Actually, when we using the MicroPython, should be aware of the Python programming.
A little bit, I think. Python and MicroPython are same actually. MicroPython is a lightweight version of Python.
Madam, actually, I didn't much aware of the Python programming. I'm aware of only the C plus programming.
Uh, it's okay actually. If you want to go
Uh,
ahead with C++, it's totally fine.
uh, so, what do you prefer for C plus plus programming software for our project, madam?
I mean, I like Python more than C++, so I prefer Python, MicroPython, but you can do C++. It's totally fine. I mean, I don't mind the language that you use. So you can use C++, totally fine. There's no like mark reduction or something if you use C++. C++ is totally fine. And I like it if you use C++. It's actually more complex than Python, I think. So if you can work with C++ easily, then it's totally good. You can, I mean, go ahead with it.
So we can use the C++ code in using VS Code with the extensions.
Mm-hmm. Yeah.
Okay.
Yes. Yeah. Thank you. We were talking about the ESP32 microcontroller. So for the project, I think you will be using the ESP32. And so I think it's good that if you can have a good understanding about the ESP32 microcontroller. So we have different pins available. So for the different pins, there are different applications, and those uh, applications are uh, uh, we need to learn about for what applications these pins are used for, basically, and we so that we can use these pins in a more optimal manner. So we'll try to see. So this is basically ESP32 microcontroller, and we have basically like uh, about 48 pins in total in the controller board. There are about 48 pins. So there are, I mean, when we categorize the pins, there are many types of pins. When we talk about the input output pins are available, um, and they are available on the sides of the board. And then we have the boot. Uh, I mean, there's a switch to which is called boot, and this switch is used to download the code into the controller. So sometimes you don't really need to press that every time. So like initially, once you are using the code, sorry, once you are using the board, then you sometimes if you feel that the code is not getting loaded into the into the chip or into this board, then we can press that switch and then we can allow the code to be uploaded there. But we don't need to always press that button. That the software that we are using or the IDE that we are using will allow us to upload the data directly to the controller uh, using its methods, the protocols that it use. So basically, this this switch is used to kind of download or put the code into the board. While so after you have run the code in your IDE, compiled it, then you need to upload it to the controller, right? So once you're doing it, you can try to press the boot switch, and then you can see that the code is getting uploaded there. And then the USB port is there to provide the data transfer and then to provide the power supply that is needed by the system. So it is the USB port is used for both power transfer and also for the data transfer. So we have the EN switch. The EN switch is like basically the reset switch. So once you are initializing the board, you can uh, press this EN button. So this EN button is used to reset the code, whatever that is installed already in the chip. And then we have input output pins, as I said before. And then the chip in the middle is the chip, the chip, the chip which contains all the components is basically the known as the ESPW room 32. So the chip inside the controller is known as the ESPW room 32. So it is basically it is the one which contains the the different uh, I mean uh, it which contains the different components um, related to the memory and related to the operating system and uh, uh, other applications of this controller. So I don't know whether it's visible, but in this black position, there's a antenna that that is enabling us to communicate with another device or another ESP32 module. So or any other or any other module. So those are basically basic component understanding, and there are many components in this ESP32. So um, we will see like separately, like the uh, the kind of the pins that are available in the controller. So do you have any questions so far? So about the different pins, all the data you can find in the data sheet as well. So you can basically see different the pins are allocated for different applications. So when we talk about the um, let me. So basically we have the ground pins, and we have the power supply or um, power supply pins or voltage pins, and then we have EN pin, which is known as the chip enable signal pin or chip enable pin. So we have to, I think we can get some idea about these pins when we refer the data sheet. So uh, so there are I don't know whether you can see each and every pin, but this is basically regarding the chip, the W room 32 chip, and its pin outs or the pins of that microcontroller. So there are different pins of that chip, and we can directly see that the pins are connecting to ground pins, and there are several ground pins in this controller board. So why do you think that we need several ground pins? You know, there are different types of pins in here. So we can discuss about all of them. Um, so uh, there are uh, pins for power supply, power supply, or voltage. There are voltage pins, voltage input output pins. And then we have ground pins, ground pins. And then we have input output pins, right? We call this GPIO pins, which means general purpose input output. So general purpose input output pins are there. So most of the pins are general purpose input output pins. And then we also have like communication uh, pins, like pins dedicated for communication protocols, such as SPI, I2C, UART, likewise. So when we are doing communication, from one device to another device. So uh, depending on the you know uh, communication we are doing. If we are doing serial communication, we will use serial peripheral interface communication protocol, or SPI protocol. So likewise, we will use I2C UART communication protocol, depending on how we transmit the data from our device to the other device. So in yes, in a way such that the receiver can decode the data based on that technology. So if we are sending over the data over SPI, then we define certain parameters such that the transmission happens in a specific manner. So the bit transmission follows a specific clock frequency. It follows serial communication, and then other parameters are defined. And then based on that, the receiver will know, okay, this is the frequency of receiving the data. And then based on the other parameters, the receiver is able to cut off the data appropriately and decode the data from that received data stream. So basically those things are like actually regarding the communication protocol that we use to transmit the data from the microcontroller to another microcontroller, or from the microcontroller to another device, or any other communication that can happen from like the microcontroller to access point, or also on. So when we talk about the different pins uh, that are used, uh, as I said, we will have power supply pins and power supply pins we will have. So basically there are like voltage pins, input output, and so voltage input is given by the voltage in pin, or V in. Voltage output is given, or output voltage can be measured from the microcontroller through the 3V3 pin. There's a pin called 3V3 pin in the microcontroller, right? So in this, actually this diagram shows only the pin outs of the chip, right? The chip is called the ESPW room 32. So these pins are that are coming from the chip. So when we look at the board, there are other pins surrounding this chip. So um, when you look at the pins, you will be able to see the 3V3 pin, or the pin which is known as 3V3, which has the output voltage or of 3.3 voltage. So it can give a maximum voltage output of 3.3 voltage. And then for the input, we can give a maximum of about, I think, like 0 to 5 volts we can give to the system as input. And without any problem, it will take in that voltage. So, uh, so we can, so we need to know these threshold voltages before using our microcontroller for any tasks. We need to know like what is the maximum voltage we can supply to this microcontroller board. So if we go beyond that, we will face a lot of burns and a lot of damage done to the controller. We can't use it again. So therefore, we have to check these data in the data sheet, and then we need to use the correct voltage. So those are the things related to the voltage input output pins. Apart from that, we have set of like GPIO pins, or general purpose input output pins. So these input output pins can be divided mainly into analog pins and digital pins. So analog pins are used for basically, analog input and output operations. This is used for analog input and output operations. So we can provide analog inputs to the board, and also there are specified pins that are giving analog outputs, right? So analog pins, right? We can use some analog pins to give analog input, and then some analog pins or some pins to get analog output. So about that, we have to know like some specific details regarding the pin configuration. So right, so the pin configuration of the ESP32. So um, once you actually uh, refer the data sheet and the other resources available regarding the pin configuration, we will be able to see exactly uh, what are the pins and what pins are for what. So according to the data resources we have, in the data sheet, we were able to see that there are 18 analog to digital converters, right? So ADCs. So analog to digital converters are there, about 18 pins, and these are able to convert the analog signal that we input to the microcontroller to a digital signal. So easily we can give the digital signal to the system using these pins. So there are 18 pins of that. So right, so we can do that. Apart from that, there are two digital to analog pins. So two DACs, digital to analog pins, that can provide an analog output from the controller to the external device or any other device that we are connecting our controller to. So two DAC pins are there, 18 ADC pins are there. So do you have any questions? So these data are related to actually from the data sheets and also from the resources regarding the pin configuration of ESP32. Apart from that, we also have digital pins. So the digital pins are useful for um, digital signals, digital signals or digital inputs and outputs. So these digital pins are useful when we are giving a digital input or digital output, and then when we are giving digital input and when we want digital outputs. So we can uh, so we can actually provide digital signals with 0 and 1 voltage levels. So we can actually we can create the we can input voltage levels that correspond to 0 and 1, and we can obtain the digital data. So the 0 will be represented by a certain voltage, one will be represented by another certain voltage. Let's say this is 3.3 volt and this is 0 volt. And by varying these voltage levels, the uh, microcontroller is able to provide digital outputs. So that is what I would like to talk about, the analog pins and digital pins. Do you have any questions about that? Sorry, I have talked about the GPIO pins. However, like I have drawn this arrow for the ground pins. So what I talked earlier was about the analog pins and now digital pins under GPIO. Okay, so this should be analog and this should be divided into analog and digital. So GPIO should be uh, divided as either analog and digital pins. So I think I did not discuss about the ground pins. So the ground pins, right? So the ground pins are uh, uh, are actually providing the ground or reference plane to the um, or it is giving us access to the reference plane of the chip, right? So the the whatever the ESP32 microcontroller chip, right? ESP32 module has a certain ground layer, right? It has a ground layer. And so once we connect our devices sensors to this ground pin, it is connected to the ground layer of the ESP32 module. So all the ground pins that we have here are connected to that same ground layer. So there's only one reference plane as the ground layer. There can't be different grounds. There can't be different ground levels. There's only one ground for the entire microcontroller board. And so that is, I think, is the necessity. So like there are different ground pins in here, multiple ground pins here, but they will all connected to the same ground layer. So uh, there are multiple ground pins available, multiple ground pins available. So the reason for having these multiple ground pins is to reduce the interfering noise, to reduce the interfering noise. Right, to reduce the interfering noise impact to the uh, uh, interfering noise impact to the circuit. So once you are having a good ground, once you're having a good ground connection for your circuit, you have connected the ground pins correctly to the devices that are connected to this module, then we will have less noise in our signals that we process, and therefore we'll be able to get the information very fast from that signal. But if we don't have the good grounding of the signals, we will have some noise coming from coming due to the imbalance in the voltage and other reasons. Apart from that, multiple ground pins enable us to prevent ground loops. Prevent ground loops means ground loops. Ground loops means like there could be different positions or different points in the circuit that acts as the ground. However, it's actually that the different points that act as the ground have different voltage levels. So because of that, there could be some loop that is forming between the one ground pin and another ground pin. So likewise, there could be some voltage between the ground points, ground levels. There's a voltage difference between those 2 points. Then there's going to be a loop that is formed between the two different ground points, and that loop will result in, you know, causing damage to the circuit. Could be some short circuits or some current leakages, and that current that is leaking will damage the microcontroller. So I think like it is uh, essential that we maintain this ground level uh, very well. And the having multiple ground pins help us to connect the other devices, right? This helps us to, right? This helps us to have multiple ground connections. It help us to connect to other devices, right? Help to connect other devices. Mm, right? Help to connect to other devices. Help to connect to other devices. Um, that will have multiple ground connections. That have multiple ground connections. If the other device is having multiple ground connections, we need to have multiple ground pins in our microcontroller. So to enable that, we have multiple ground pins in our microcontroller. So uh, that is basically regarding the ground pins. So I will erase this. Do you have any questions? All right. So when we talk about the other section or other types of pins that are there are other types of pins that are like communication protocol assisted. I mean, uh, I mean pins or communication protocol based pins. So, uh, so as I said, like we have this. We have SPI pins, right? So we have SPI uh, interface or SPI protocol assisted pins. So also we have I2C protocol assisted pins. So UART assisted pins. Likewise, we have different pins. So these pins actually are defined in the datasheet itself. These pins are defined in the datasheet itself, and like the datasheet defines like which pin can be used for which communication protocol based communication. So if you are using SPI communication, then we need to, like connect the pins of pins uh, in an appropriate manner such that the SPI communication can happen. So SPI is like a communication that has standard, method of communicating. So it needs standard amount of pins, input output pins, and SPI needs those standard amount of pins to to be connected to the other device, which will retrieve the data. So those pins, those specific pins that can be used for SPI are defined in the data sheet, or else those pins can be found using a code by running a code in the IDE that we are using. So we can find the different pins that are used for the SPI communication, for example, and by following by following the normal standard way of connecting these pins to the other device, such that the communication will happen in that protocol, then we can actually establish the communication between the two microcontrollers or the two devices that are communicating. So likewise, I2C protocol, UART protocol, and I2S protocol, those protocols are having some dedicated pins in the microcontroller, in the ESP32 microcontroller, that enables um, that enables that specific communication. So those specific pins can be found in the data sheet. These are already available in the data sheet. So for these communication protocols are used for different applications. Depending on the application, uh, the um, the users will use the specific pins. So that is basically regarding the communication interfaces related pins, communication interface related pins. Um, Another type of pin I would like to also mention, there that give uh, like one thing is like PWM outputs, right? Or pulse width modulation outputs, pulse width modulation outputs. So these pulse width modulation output signals are given by this PWM output pins. So these output pins will create a PWM signal. So the PWM signal can be used for different applications. So we can use it to, like control a motor, and PWM will reduce the maybe the noise impact due to its nature. So uh, anyway, we can produce PWM signals as output signals from this ESP32. Another important type of a pin is the touch pin. Touch pin is another unique feature of this microcontroller board, and it is also one of the GPIO pins. Is one of the GPIO pins. That means it can take input and can give output. So we can give input to this touch pin, right? So it is one of the GPIO pins. So basically, like according to my understanding, we can give like some kind of a voltage or some kind of a touch on the pin, and then we can generate some voltage inside the microcontroller respective to that, and we can get some work done. This is useful for situations where we want to implement touch pads, or some kind of a kind of pressing action where we want to touch and like press a small button, or some kind of a pad, or some kind of a object or surface, and then we want to get some output. So in that case, we can use the touch pin. So we can use this touch pin, and then we can get some reaction once we touch that pin using maybe a touchpad or some kind of button, a switch, so on. So these touch pins is an additional feature which is available in ESP32 when you compare with the other microcontroller boards such as like Node MCU and so on. So ESP32 has these touch pins, which is a special feature of that microcontroller. So these touch pins can be used to implement touch pads, or like some like switches and buttons on which this microcontroller will start working on. Another thing is I wanted to mention there's a pin called EN pin in this microcontroller, which we call as the enabling pin. So enabling pin. So this enabling pin is used to enable or disable, deactivate to activate or deactivate the chip. So this enabling pin is used to activate or deactivate the pin. Activate or deactivate the chip, right? So this is used to activate or deactivate the chip, the EN pin. So using this EN pin, we can actually save energy. We can save energy by using it optimally in situations where we don't need the functioning of the ESP32. We want to keep it asleep, and then we want to use it only when we need it. So those are the features of this EN pin, which is useful for saving energy. Right? So I want to know one thing. Do you have the access to the attendance tool that we have in a SLTC?
Madam,
Do you have
actually, in my another module, the lecturer has created the login, but I don't know the for this it will work or not.
uh-huh. Okay, I will share with you a code. You can try to see whether it works for you. I know the time is over, but maybe you can try to log in using your SLTC ID and then input this OTP and verification codes.